Hello, this is Nitin Dahad with the Times. I'm talking to a couple of guys at the Marvell Industry Analyst Day in Santa Clara. Mark Kuemerle, hello, Mark.
Hello.
And Wolfgang Sauter. So they're responsible for some of the custom silicon and packaging at Marvell, and we've had some interesting presentations from you today. Mark, maybe you could start about some of the challenges on silicon scaling and packaging scaling.
Sure, yeah, sure. So one of the things that I shared today with the group is that as an industry, we're really struggling in terms of real silicon scaling, or what we're used to is Moore's Law, that's providing us a benefit from node to node that allows us to kind of double the content and double the performance of a device every generation. So one of the things that I shared was that without real technology scaling, we have a need for more and more silicon to achieve performance goals each generation, and that is actually causing quite a number of challenges.
And before we go into some of those challenges, just remind us, I think, your role at Marvell.
Oh, sure, yeah. So my role is the CTO of custom silicon, custom solutions at Marvell. So I actually lead a team of architects who define a roadmap and work closely with our customers to define custom solutions.
And one of those was the custom accelerator, HBM, that we talked about at the presentations today, which is not what we're talking about here. But
yeah, custom ML accelerators, AI accelerators are near and dear to us, and we spend a lot of time thinking about them and working on ways for optimizing that silicon and solving some of the scaling challenges that I spoke about today.
Now I think one of the reasons you're going custom is obviously that silicon scaling challenge, and then you're building vertically. But you mused about some of the real challenges of scaling silicon, but also the packaging.
Yeah, absolutely. So one of the things that we've found is that because we're seeing more and more limited silicon scaling, we have a need to have more and more silicon to actually achieve a performance scaling from generation to generation. Silicon not scaling, more silicon means that we need to have a larger and larger package size, which carries that silicon and attaches it to the rest of the system. And that increasing package size is causing a number of challenges.
Yeah, the irony is there's a standard JEDEC tray, which hasn't changed for years, and nobody's working on increasing that size, but it doesn't matter because we're all building vertically anyway. Is that right?
Yeah, well, I think it is true that we're actually going to see fundamental limitations in package sizes. And we've had this need to have more and more silicon. I think things like 3D integration are going to help us to kind of stave off that challenge for maybe another generation. But it's something that we're going to have to face as an industry and figure out how to solve.
Okay, now we're going to turn to packaging. So Wolfgang, I don't know if you want to take the mic and just talk a little bit about some of the summary of the key things. I mean, my key takeaway, I think I didn't realize that before, but the cost of interposers, and you don't really realize how expensive it is.
So I'll start with an introduction also. My name is Wolfgang Sauter. I'm a senior distinguished engineer in Mark's team. So we do a lot of the custom AI processors, the architecture for those, and then also trying to develop the roadmap of how we can not only lead the technology, but also bring the technology to embrace entirely new concepts in packaging and align with the suppliers so that it's ready for tomorrow's products.
And some of those new concepts are?
So there's to solve Mark's problems, we need more and more integration, closer and closer together. So there's multiple ways to do that. Most of them include not just in-plane stacking, but out-of-plane stacking through 3D, 3.5D, and maybe even multiple interposers stacked on top of each other to solve that interconnect problem.
And I mean, you were conveniently trying to sort of bucket into different areas, like this is a chip scaling problem, this is a packaging scaling problem, but there's so many things now that are in between, and you talked about some of those. Just highlight some of those examples here. Like all the things that don't fit either of them, they need to be addressed.
You really can't stick it into buckets at all anymore. There is not a chip bucket anymore and a package bucket, because even if you think about a piece of IP, if you can't escape it on a substrate or on an interposer, that piece of IP is useless. And there's just enormous sensitivity today that to develop each piece of IP, each piece of a chip, with a real focus on what you actually do in the final product configuration.
What about the costs? I think one of the other things you talked about all the different packaging and interposers and just tell us a little bit about those issues on costs.
Yeah. So if we go 20 years back or 10 years back even, the business model for custom logic was about 30% of the cost was package and test.
Yes.
Today, I would say it's 30% of the cost is the ASIC, and the rest is package and integration. So it really has flipped upside down on where the cost comes from. Silicon interposer, or interposer in general, is one very, very big part of that equation, and how to cost optimize the 2.5D interconnect for a product.
And between both of you, I mean, what are the key things when you're talking to customers? You can't talk in like just individually anymore. You have to talk about the whole solution, I guess. From chip to packaging.
Absolutely, yeah. Again, going back in time, the architects used to only talk about chip technology and IP. Today, when we talk to customers, it's 50-50 split between chip and architecture, and packaging is the other full 50% of a meeting agenda today.
And in terms of what advances you're seeing in terms of packaging with your customers, what can you say?
Oh, it's incredible how fast it's evolving. So many technologies are coming up on the market so quickly that it's hard to even assess them all properly, and they're all needed because the leading one will always be the most expensive one. And we need that to ramp a product, but at the same time, we also need to cost optimize. So we need to work on that N+1 or the next generation solution that will enable us a cost-reduced option. And
I guess, Mark, from your point of view, with speeds increasing, and we're going to get 800, 1.6, and the roadmap shows quite rapid acceleration in that. Where do you see things going, and what are the challenges that you need to address?
Yeah, absolutely. So I think the real key that you're bringing up is that data rates are increasing. That's creating a bigger and bigger challenge for really anything that actually goes through I'm going to say it, the word package, anything that goes through a package. And it's becoming more and more difficult to actually move data. So we're really seeing a transformation in the industry where we're going to start seeing solutions migrating more towards unconventional interconnect that's actually co-integrated into the package that allows us to really achieve much better performance than we would if we were actually going through a traditional package and board interconnect. And I think that's going to be another transformation and an evolution. It opens up this opportunity. We talked about limited scaling. These things like differentiated interconnect for integrated copper or integrated optics really gives us an opportunity to scale system performance in a way that helps account for the slowing of Moore's law.
And I think optics was one of the questions that was raised in the Q&A, but when are we going to see a more sort of deployment of the optics in that?
Yeah, and it's something that we're working on quite a lot at Marvell, really making sure that we've got pioneering optics that are going to allow the data center to have absolute maximum connectivity, even higher bandwidth density connectivity than we have with traditional SerDes interconnect today, but at an extremely reduced power envelope and enabling features that our data center customers need in their optical integration to help them build systems that really scale out to the millions of XPUs over the coming time.
Well, you talked about thermals. I think that's another conversation. We won't talk about it.
Oh, yeah, we could spend another half an hour on that for sure.
So, final thoughts. What are the key things that you want to get across from today?
I think the one thing that I wanted to share is, as an industry, we definitely need to work together to come up with approaches to allow us to continue to build these systems and to be able to scale these systems. Because at Marvell, we're not the only people who are encountering this problem, and it's something that we're definitely going to have to work together as an industry. The other key thing that I wanted to share is that there are technologies that can help us to achieve scaling of these devices over time, and that's something that we're spending a lot of time and effort here at Marvell to develop, and would love for the opportunity to share those with the rest of the industry.
And Wolfgang, any final thoughts from you?
No, absolutely agree. It takes a lot of participants to develop these kind of technologies we need today, and it's not something we only do internally. We rely on a lot of partners and suppliers to help us on that path, and it takes an extremely good relationship to do that successfully.
Well, Mark and Wolfgang, thank you very much for some great presentations and conversation. Thank you.
Thank you, Nitin.
Thank you, Nitin.
Thank you.